Okay, so we are going into a very important derivation. Okay, so we are going to find out what is going to be the electric field due to an electric dipole along axial line. Okay, what it means actually, right? Let me figure it out. Basically, you know very well, a dipole is nothing but two equal and opposite charges separated by a small distance, which is going to be 2d. Correct? What I take is, let me place this negative charge at position A and this positive charge at position B, and let me have a line of joining between these two, and let me take the center between these two as O. Clear? I am taking the center as O. Okay. Now I am going to keep a point somewhere here, say it is going to be P, at a distance of R from the center of line joining both the charges. Okay? Be careful, listen carefully. I took a dipole and I kept a point in between as O, and another point I am keeping along the axis of this dipole, and I am going to see what is going to be the electric field at this point due to these two charges. Right? So இதில் என்னென்னலாம் நம்ம எடுத்துக்க போறோம் அப்படின்னா principle of superposition எடுத்துக்க போறோம், and electric field due to positive and negative charges என்னன்றதை நம்ம எடுத்துக்கிட்டு அதுக்கப்புறமா we are going to derive. Is that clear? Right? Okay. So இப்போதைக்கு வந்து we have taken two equal and opposite charges separated by distance of 2d. Right? Now can I divide this as d for this part and d for this part? Correct? Okay. Next, this distance is r, and what will be the electric field due to negative charge for this point? Electric field will always move towards the charge. Correct? So let me take this as electric field due to negative charge. Okay? Is that clear? Right. And let me take the distance between this minus q and this point as r up to this plus d. So it's going to be r plus d. Are you clear with this? Right. Next, what will be the electric field due to positive charge due at point P? Exactly. So it is going to be away from this charge E plus Q. And what will be the distance of separation between plus Q, B and P? This distance. Up to this is R and this is D. So this is going to be what? R minus D. Okay with the construction part? This is very important part. So what I took a dipole and I drew a line joining these two charges, and along the axis of these two charges I kept a point, and I am going to find out what is going to be the electric field at this point. Did I justify the topic? Electric field due to an electric dipole along the axial line. Is that clear? Right? So now what is our role? We have to find out what is going to be this electric field due to negative charge and positive charge, and I have to add those two, right? So that I can find out what is going to be the total electric field at that point. That's it. Okay, fine. So now I'm going to take the magnitudes first. Okay, so let me take electric field due to positive charge. So what is the formula for electric field due to a point charge? E is equal to K Q by R square. Remember this? Yes, this is the magnitude of charge for a point charge, right? So magnitude of electric field for a point charge. Okay, so now for a point plus charge, K is going to be same, right? Q is going to be also same, divided by, what is R now? For positive charge, it is going to be R minus D whole square. So R minus D whole square. Okay, now if I take it as a vector, the direction of electric field will be along BP. B length peak dana podu. So it's going to be along BP. Is that clear? Let me take this as first equation. So far any doubts? Right. Next, electric field due to negative charge. Right? So now K Q by R plus D the whole square. Yes? Yes. But vector, what charge is it? Negative charge. So minus. Yes? And it is going to be along? It is going to be this way. So it is going to be along PA. Let me take this as second equation. So now you got two electric fields. So one is going to be due to positive charge and the other one is going to be due to negative charge, right? So now what we have to do? Total electric field is nothing but E plus Q plus E minus Q, right? So E plus Q was what? K Q by R minus D whole square plus K minus Q by R plus D the whole square. Fine. Now K Q common. So I'll be having 1 by R minus D whole square minus 1 by R plus D whole square. Correct? Can I take LCMs? K Q R plus D the whole square minus R minus D the whole square divided by A square minus B square. So what you will get? R square minus D square whole square. This A plus B, A minus B, A plus B, A square minus B square, or square already irka, so whole square. Is that clear? Right? Yes. Now expand it. R square plus D square plus 2RD, correct? Minus R square plus D square minus 2RD whole divided by R square minus D square whole square. Clear? So when you are multiplying minus here, what you will get? So it's going to be KQ R square plus D square minus 2RD, sorry, plus 2RD minus R square minus D square plus 2RD. Correct? Whole divided by R square minus D square whole square. Right? So you can cancel these R squares and D squares. Correct? So what you will get now? KQ 4RD irkuma, 4RD divided by R square minus D square whole square. Right? Now what I am going to do is, I am going to find out what is going to be the electric field due to an electric dipole. So there should be a component relevant to electric dipole. So what I do is, this 4, I am dividing it into 2 into 2. Okay? So I rearrange the equation for our convenient purpose. K 2K nu vechikalam. 2K ஒரு 2 போயிடுச்சா? இப்போ next உள்ளே யார் இருப்பா? 2QD into R ன்னு போட்டுக்கலாமா? Whole divided by R square minus D square whole square. What is this 2QD? Dipole moment. Correct. So can I now write like 2K or K 2PR divided by R square minus D square whole square. This is going to be your total electric field due to an electric dipole along axial line. Is that clear? Right? Now we can go for special cases. So the equation which we got was K 2PR divided by R square minus D square whole square. This was the electric field which was found due to electric dipole along axial line. Now suppose this distance is very much greater than the dipole distance. What I mean is, we saw this part, right? So if this distance is very greater than, I mean, it's very lesser than this distance, or otherwise this R is far away, right? So if R is very far away, this distance of separation will be negligible. Imagine, no, இப்போ நீங்க வந்து இங்க tube lights இருக்கு. இந்த tube light நீங்க கிட்டக்க பாக்கும்போது அந்த straight line தெரியுது. If you are moving away, no, it will look like dot. Yes, you cannot see the shape actually. So the distance between the two ends will be almost negligible. Likewise, what we do is, we are going to consider that the distance of separation between the centers and the point is very high. So we can neglect this distance of separation between the charges. So if that is the case, so if I take R is very much greater than D, can I neglect this? So the final equation will turn out to be K 2PR by R power 4 3. So the electric field now turns out to be K 2P by R cube. So this is going to be the electric field due to an electric dipole along axial line. So can I mention it as axial because we have another derivation? Okay, again electric field is a vector quantity, correct? So vector form, how it will be, is equal to K 2P vector divided by R cube, right? And see here, you have dipole moment, you have electric field, correct? So we saw that dipole moment will always be opposite to electric field, but in this case it will not be like. Why? Because if you see here, the final electric field will be in which direction? It will be along positive direction. Why? Because the distance of separation is very less comparing with negative charge, correct? So positive charge the distance of separation, positive charge கம்மியா இருக்கு. இது இங்க இருக்கலாமா, பாசிட்டிவ் சார்ஜும் இந்த பாயிண்ட்டுக்கும் நடுவுல இருக்க டிஸ்டன்ஸ் கம்மியா தானே இருக்கு இத கம்பேர் பண்ணும்போது, இல்ல? அப்படி இருந்துச்சு அப்படினா if R is very much less, E will be high. அப்போ net electric field after completing these derivation along which direction it will be? Along positive direction. Negative direction ஓட distance அதிகமா இருந்துச்சுனா electric field கம்மியா இருக்கும், ரைட்டா? நம்மளோட final value of electric field will always be along the direction in which the magnitude is greater. Likewise, dipole moment ஓட direction இங்க என்ன? Negative to positive. அப்போ இதோட directionோ net electric field ஓட directionோ same directionல இருக்கா? Yes or no? Yes. அதனால தான் நமக்கு net electric field வந்து it is going to be positive. புரியுதா? The dipole moment's direction and the electric field direction is along the same direction. அதனால ஃபைனலா வந்து electric field ஓட direction வந்து பாசிட்டிவா இருக்கு. Is that clear? Right? So இதுல எழுதிக்கோங்க. Electric field, net electric field and dipole moment are along same direction. எந்த directionல? BA along, அதான் along BA, correctா? Yes. So this is going to be the electric field due to an electric dipole along axial line. This is very, very important 5-mark question. And also if you want, you can expand it and write it also. Okay. So எப்படினா, okay.